Example 1 here on numerical integration is taking a look at numerical integration. So here all we want to do then is simply find an approximate value for this integral here using 5 strips, and we want to give the answer to 3 significant figures. So the first thing we need to do here is find the width of each interval, and to do that use the following formula. So h is equal to b minus a divided by n. So in that case, b is represented by the upper limit of our integral, so that's going to be 3, minus a, which is the lower limit, so 3 minus 1, and we divide this by n, where n is the number of strips, so that's 5. So in that case, this would give us 2 over 5, or 0.4. So in that case, what we know then is the x values are given by x0 equals 1, x1 is equal to 1 plus 0.4, giving us 1.4, x2 is given as 1.4 plus 0.4, giving us 1.8, and so on. So our final one here will be x5, and this is equal to 3. So we can now work out the corresponding y values, which represent the heights, using the following equation here. So y equals the square root of x cubed plus 2. And in that case, what we obtain here is the following table of values. So when x is 1, we obtain that y is the square root of 3. When x is 1.4, we obtain that y is equal to the square root of 4.744. So here now we can find the approximate value. Now we just use the trapezium rule. So here all we do then is substitute the y values into the following formula. And let's use a different pen colour here just to highlight this. So this is the integral from a to b of y with respect to x. And this is simply equal to here, or approximately, so if I just get rid of that, sorry. So this is approximately h over 2. So h over 2 times y0 plus our last term, yn, and then 2 lots of all the other terms. So that's going to be 2 lots of y1 plus a y2 plus all the way up then to our penultimate term, yn minus 1 there. Okay, so in that case then, all we simply need to do here is use the appropriate terms here for y0, y1, y2, all the way up to y5. So in that case then, we're looking to find the integral from 1 to 3 of the square root of x cubed plus 2, okay, with respect to x. So here, this will be approximately h over 2, so that's going to be 0.4 over 2, 0.4 over 2. So now in the square bracket here, well, our first term y0 is the square root of 3, and our yn is y5, so that's the square root of 29. Okay, so plus the square root of 29. Now here, this will be quite tricky to fit fully on the screen, but let's give it a go here. So it's going to be 2 lots now of y1, so that's the square root of 4.744. So essentially now we do 2 lots of these square roots here, okay? So we're going to do 2 lots of these terms here now, so we will write out in full. So that's going to be the square root of 4.744 plus the square root of 7.832. We'll just write underneath here plus the square root of 12.648, and finally plus the square root of 19.576 there. Okay, that gives us everything we need there. So all we need to do now is evaluate this on our calculator to get the approximate area, or the approximate value for this integral. And what you'll find here is that our approximate value to 3 significant figures, as we're asked for here, is 6.61 there. Okay, so that gives us the solution to example 1. Example 2 here on numerical integration is taking a look at using more intervals. So using more intervals gives you more accurate approximations, and let's demonstrate that here with this example. So we want to use the trapezium rule to approximate the area of the integral here of 2x cos 2x between 0 and 0.5 to 3 decimal places. And we're going to use n equals 2 and n equals 4 here. So let's start with n equals 2. So the first thing we want to do here is calculate h. So h is equal to the upper limit, 0.5, minus the lower limit here of 0, and we divide that by n, which is 2 in this case. So that simply gives us 0.5 divided by 2, which is 0.25. Okay, so therefore x0 is equal to 0, x1 is equal to 0.25, and x2 is equal to 0.5. Okay, so what we do now is we substitute these values into the equation, and that will give us the y values. So therefore y0 is equal to 0, y1 is equal to 0.4387, and y2 is equal to 0.5403. Okay, but these go on for a bit. Okay, so that gives us our y0, y1, and y2 values. So now all we need to do is use these values for the trapezium rule formula. So the integral from 0 to 0.5 of 2x cos 2x, okay, with respect to x. So here, using our approximation then, trapezium rule, we do h over 2, so that's 0.25 over 2, so 0.25 over 2. And remember, we do y0 plus the last one, which is y2 in this case, so 0 plus 0.5403. But just to make sure we have full accuracy here, I'm going to use this definition here that we've used. Okay, so 2x cos 2x. Okay, so I'm just going to substitute those values in. So in that case, what we get here is our first one, which will be 0 anyway, so we can just write that as 0. Okay, so that's our first value, plus 2 lots of the middle term here, which will be 0.5, so plus 2 lots of 0.5 cos 0.5, so that's what we meant there by the 0.5, and finally, for this 0.5403, that corresponds to plus cos of 1 there. Okay, so here now, if we just evaluate this, what we find then is this is approximately 0.177. So all we need to do now is just repeat this, but for n equals 4. So we just clear all this, make sure you take a note here of what we got. Let's repeat this for n equals 4. So for n equals 4, okay, so for n equals 4, again, we just calculate h. So h here then will be 0.5 minus 0 again. So upper limit minus lower limit, and divide that by n, which is 4. So that would be 0.125 here. Okay, so therefore x0 will be equal to 0, x1 will be 0.125, x2 will be 0.25, and like you can see, this will go on then up to x4, which is equal to 0.5. Okay, so now what we want to do then is substitute these values into the equation, giving us our y values. So here, if we write them out in full, y0 is equal to 0, y1 is 0.242, and again what I'll do here is give the approximate answer, but for the solution, or when we're using our approximation in the trapezium rule, I would use the exact form here. Okay, so y2 is equal to 0.4387, y3 is equal to 0.548, and finally y4 then is equal to 0.5403. Okay, so what we want to do now is just use these values with our trapezium rule formula. And what I'll do here is just clear the work we've got so far, just so we've got enough room for this full approximation. So the integral then, from 0 to 0.5 of our expression here, so this is 2x cos 2x dx. Okay, well here now, our approximation is given by h over 2, so that's 0.125 over 2. And here now, again, like I said, I'm just going to use the exact form, but the first one will be equal to 0 anyway, so that's 0. The last term here, remember that's going to be plus cos 1, so we get plus cos 1. So I'm going to put that at the front there, just so we've got the first term, the last term, that's our y4. And then for everything else, that's going to be 2 lots of everything else. So we've got two lots of 0.25 cos 0.25 plus 0.5 cos 0.5, and finally plus 0.75 times cos 0.75. Okay, so that gives us everything we need there. Okay, don't forget to close our bracket here. So we've got two lots of 0.25 cos 0.25 plus 0.5 cos 0.5, and finally plus 0.75 cos 0.75 there. Okay, so that was our y0, our y4 there, and two lots of everything else. And what we get here for our approximate value is 0.187. And by comparing this with the exact answer that can be found by using integration by parts, the exact value for this integral is 0.191 to 3 decimal places. Okay, so we can see that using n equals 4 gives us an answer which is closer to the actual area, okay, compared to when we use 2, or n equals 2, for example. So that gives the solution there to example 2 for numerical integration.